Thank you. All right, thank you for that introduction. So, AI will kill all living plants. That is probably the least concern the farming industry should have, and probably the most ridiculous concern I've heard in terms of AI and farming. My name is Johansson, as you mentioned there, the COO of Optima Planta, and we are a company that is pushing the sustainability and efficiency of farming. And I'm very excited to be here today and share our perspective and our vision of what is the farming industry of tomorrow and what is the role of data and AI in terms of that. And let me assure you, no, it has nothing to do with a Terminator Skynet trying to kill all plants. Rather the opposite. I'm quite convinced that data and AI is the seed that will allow the farming industry to grow into a completely different beast where we use way less resources to produce even more. And that will have significant effect. On one hand, saving insane amounts of money for our societies, but more importantly, drastically reducing the climate impact. And that's a pretty big statement, I know, and I will get into that. But first, let me just briefly introduce myself, although you already did quite well. But basically, I studied here in Gothenburg at Chalmers University of Technology, mixing a little bit of engineering with business, and then a master's degree in entrepreneurship and business design. Started a other tech company in 2016, where we wanted to help investigative journalists by protecting their data and their sources with a real-time encrypting memory card. And now fast forward to 2019, that's when I met Lennart Sör, the founder of Optima Planta, who at the time had a very cool looking prototype of an advanced farming system. And we had a discussion about what is the farming of the tomorrow, what does the future look like, and actually what is the role of data and AI in that. And it was a very, very exciting conversation. But to understand what we see as the future of farming, it's important to also understand the history of farming. And that started around 12,000 years ago. That's when we first started farming, and that's a very, very long time. And during that time, people have tried things, tested things, experimented. Some things worked, some things didn't work. And during all of those thousands of years, knowledge has been passed down from generation to generation and so on and so forth. However, that knowledge has always been somewhat limited. Limited in the sense that you could only grow the crops that you had access to. And you could only grow the kind of crops that worked in your specific environment. And you were very dependent on that specific environment. Is it rainy? Is it sunny? Is it warm, cold? All of those things. And then something happened around 100 years ago where we started really developing the Industrial Revolution, and we saw machinery getting into the farming industry and really making it more and more efficient. You can grow more using less. And you also started getting more and more knowledge when it comes to biology, chemistry, plant physiology. And all of this has added to the fact that we can now grow much more than we could back then. One example of that is corn production. We can grow about 4 times more corn in the same surface area as we did 100 years ago. And this is very important because, well, the farming industry has a lot of challenges still today. If we look at the finance side of things, it is a low margin industry in general, and the costs are increasing. The costs are increasing due to oil prices increasing, gas prices increasing, electricity increasing, transport costs in general, labor, operations in general. So basically heating and running a farm just costs more. And that's generally a bad sign in a low margin industry. And then we also see that, well, we only have one planet. And that one planet has quite a limited amount of resources. So we kind of need to use that as best as we can. And at the same time, we see that there's going to be about 1.6 billion more people by 2050. And that's all fine and well. But you have to also take a look into the fact that we're already using 70% of the fresh water within agriculture today. And we have already ruined about 40% of the, 30% of the arable land the last 40 years. Coupled with that, we're also sending plants all over the planet all the time, leading to massive CO2 emissions as well in the transport. So looking at all of this, it's quite clear that, yeah, we do need to find ways to grow more using less. And that's where I think that AI and data comes into play. And we can already see some really exciting applications in this. If you look at a greenhouse today, you're fairly likely to be able to see that they have some sensors at least. Some sensors perhaps detecting the temperature in the room, or some other parameter, and hopefully also some systems to actually change that temperature depending on what you want to do. Not always the case, but sometimes. And you also have satellites today taking pictures of the outdoor farming and helping to guide based on also weather forecasts combined with what they see in the soil to when you need to add more nutrients, fertilizers, and other things. So there are tools for farmers already that is utilizing data only. And then you also have the computer vision in terms of anomaly detection. It's fairly easy today to have cameras to take pictures of a lot of different diseases and injuries in plants. So you can get yourself a large database of, okay, so what is the different things that you can see on plants to determine whether it's sick, has an infestation, a virus, what have you. And then you can combine that with some machine learning algorithm and of course cameras in the greenhouses and be able to detect those things when it happens, cutting the time of finding this out drastically. Meaning of course that you can fix it before it spreads to larger areas. So this is already making quite an impact in the farming industry. But there's still something really big that we feel are missing. And that's the thing that can really drastically take the next step of reducing costs and using less resources to produce more. And that's if you imagine one giant brain that knows pretty much everything about all plants and pretty much everything about how different plants can affect the environments, can affect the growth of different, how different environments can affect the growth of different plants. And not only does it know exactly how different environments affect the plants, it can also use that information to guide and control farming systems all over the planet. If we reach that, then we can reduce the amount of resources used in farming quite drastically. And the reason for that is it's a cascade effect. If you look at just one parameter and one plant, let's take basil for example, and we take temperature, and then we set everything else set. So we keep the pH constant, we keep the humidity constant, we keep nutrient compositions constant, we keep everything else just set. And we change the temperature. And we keep running those experiments. We test every single possible temperature on some fine margins, 0.01 degrees even. Eventually you will find, okay, what is the exact best temperature? And by knowing this and setting that temperature in your farm, you're already reducing the resources used to grow a certain amount of crops over time. But then you start thinking, okay, so let's tweak those other parameters. We change the pH, we change the nutrient composition, we change everything else. And suddenly you realize that, oh, that perfect temperature, that is not the perfect temperature anymore. Because this is not a single variable problem, this is a very complex multivariate issue where the different parameters of the environment are intertwining in some very interesting ways to actually affect the end result of how the plant is growing. And even if you can find out, okay, so what is the best environment if you combine all of these things for a plant? Well, then you're asking yourself the question, is it still the best environment in all stages of the growth cycle? When it's a small seed, when it's a larger plant, when it's a full-grown plant? And the answer is, well, I don't know, but probably not. And the reason we don't know this, or anyone else knows this for that matter, is the data. There is a lack of data on this, so no one really knows. And the reason we have a lack of data is if we go back to what I mentioned about the history of the farming. Yes, we have grown for 12,000 years. Yes, we have passed down knowledge generation and generation, but again, it's been quite limited. You've been dependent on the weather, what is the weather, what's your environment, and so on. So there's been very limited ability to just experiment and test how different environments affect the plants. And even now, when you started growing indoors, generally what you see is like in the picture, larger open spaces where it's the same temperature, same humidity, same environment all over that greenhouse. And that means that you get basically one result per growth session, no matter how big that open space is. And that one result might also take you a couple of months to get, depending on the plants you're growing. So the data is not coming in quick, it's not coming in fast. And even if you wanted to do this, or rather, people don't want to do this, because if you have a greenhouse and you change the parameters and you experiment too much, if things go bad, you're affecting the whole your bread and butter for that whole year. So there's no real incentives for farmers to test this, and the farmers is the one having the data collecting units, which is the greenhouses. And that brings me to one of the differences I want to talk about a little bit when it comes to differences in sort of analog and digital, or however to put it, when it comes to building an AI tool or AI software, is the data, the collecting of data and the gathering of data and the existence of already existing data. In software, you can sometimes, depending on what you want to do, already get access to loads of data and start building from day one. We look at one of the most talked about tools the last year, ChatGPT. They started with 300 billion words as a starting point to work with. That is generally not the case in the hardware industry, in general. Farming industry, especially. So then you ask, okay, so how about the collection of new data once you realize that, oh, we want to do something like this? Yeah, again, if you can do things in software only and simulations, you can get stuff done very, very quickly. We had a very interesting speech earlier about the GT, the Gran Turismo superhuman AI, that was just in days of simulation time already able to beat the best drivers in the world. And again, if you take ChatGPT again, that's another example where you can just collect data continuously as long as your software tool is popular enough that people are actually using it. You're collecting data constantly at a very rapid speed. Whereas in hardware, you generally need to build something first, put that out in the real world, and then let it collect data over time. So the key difference, in my perspective, is that it's much more costly, and it takes much more time to collect data in hardware in general, farming in specific. So that leads to the question then, okay, so how do we optimize? How do we build an AI model when it comes to the farming industry, and to find, how do we find the best environments for different plants without a lot of data? So we need to basically think, okay, maybe let's just bring out the biggest hammer we have, but think of, okay, so what do we do instead of, say, full factor design and of the experiments and do test everything? Because we can't. The data is limited and expensive, it takes time. So what we went for is under the umbrella of active learning and adaptive design. We're looking at, for example, a Bayesian optimization method, especially when we start with the lower amount of samples for different plants, because that allows us to think, yes, we are very sure about this, how the sample data looks right where we have the sample data. But as soon as we step out of that, it's, yeah, we don't know. We're combining pessimism and optimism to help us guide our way forward and get a good spread of what experiments we test in order to get to the peak as quick as possible. And to do that, we have our lovely Ada, the agriculture data assistant. This is basically what she does. She's designing experiments. So what should we test? What environment should we test for this plant that we want to find the best environment for? And then she runs those tests, analyzes it, and figures out, okay, based on that, probably this and this and this is the next test we should do. So it's both sequential experiments, but also in, progressing after each other. And to our help, we have designed the Ada box. It's basically the newer, I don't know, third, fourth generation of the box I said that Lennart was having in 2019. And it is basically a closed modular growing chamber. That means that every single box is equipped with its own sensors. Every single box is equipped with its own regulation system and can be controlled in parallel with all the other boxes. So we can actually run multiple tests at the same time in a very cheap and efficient manner. As you see, these boxes are fairly small. They're about the size of an EU pallet each, so that we can really, again, think of different ways of how do we collect data fast and cheap. So this is the end design we have ended up with. And it uses something called aeroponics. As you see on this picture, the roots are hanging freely in the air. And that is really good for a few reasons. First off, it's very, very efficient, so it actually grows faster than with any other growing method if you compare to growing in soil or hydroponics, but it also reduces the variability quite a lot. Which again, if we think in perspective of, okay, so how do we collect a lot of data cheaply and with little time? That is great, because we can run less replicates and still be sure about the data we're collecting. So this is where we are, and we have basically designed a system. We have around 300 of these boxes in Uppsala right now, which is super exciting. And we have come to a point where we can already use the system to, and the data we've collected to this, to grow some plants more efficient than other methods. And more efficient and also just very great. So we have started with ornamental plants as one thing that we're right now actually using this for not only R&D but also for commercial use. So the same system that is collecting the data can also produce very efficiently and give out very good products. And we are actually starting to deliver to Blomsterlandet right now, which is one of the largest chains in Sweden when it comes to ornamental plants. And mostly they are in Uppsala for now, but keep an eye out. Soon they will be here too. And yeah, that's basically where we are and why we are so excited about the future and what the future holds. And that's, yeah.
Robin, thank you so much for that talk. And I'm going to give the crowd here their chance to ask their questions. And first, I have a question. So, what are you actually doing with these ADA box test results? So, from my understanding, you have these boxes, you're doing these tests, and you get some result from it. So, how are you then using these results? Are you then selling these insights, or yeah, if you can tell me a little bit about that?
Yeah, that's a very good question. What we want to do with this data is a few, or the data is a few different things. On the short term, of course, we want to just use the data to grow better, grow faster, more efficient, and that's what we're doing right now with the example I just mentioned with Blomsterlandet. But of course, we also are very excited to offer this technology to other users. Partly, users can use this data to make their own farms more efficient and better. That's where we're aiming for the long term. In short term, it's of course easier and to implement this in farms that already can control the environment as much as possible, because that's where you can get the most value out of knowing what is the best environment. So we're also actually selling the system in its full, basically, the system you saw. So we're selling that because that's where you can implement this value or this information immediately. But long term, we also want to sell it to farmers, just the data itself, to farmers all over the planet.
Great, very interesting. Yeah, I see we have some initial questions here, so we can start over here.
Yes, hello, thank you. Just want to ask, like, how specialized are the boxes? Can you grow like different plants, or are they specific to a specific plant? And follow-up question is this only for industrial farming, or can like somebody that just want to grow some salad buy one of those boxes?
Two good questions. On the first one, the system is extremely flexible. You can grow pretty much anything in these boxes. The only limitations we have is that the current shape and form of these boxes are that we have the upper compartment around 30 centimeters. So you're kind of limited to plants that grow up to 30 centimeters, and then you would need to take them out of the box. Which, although, since we're using aeroponics, means that we get very strong roots, means that it's very easy to actually put them out after. So in that sense, there is no limitation. And since we own this technology, we can also develop larger boxes. Say someone have the brilliant idea that they want to grow avocado trees. You can't do that in a 30 centimeter box, but we can grow a bigger one. Probably that's not going to be profitable, but you can try. And that brings me to the second question. In theory, yes, anyone can use the system. For now, we are mostly looking at organizations buying, because it's going to be a lot of support if we let people have one box each. But in the future, that's definitely something we can explore.
Great. More questions? Let's do one here now.
Hello, my name is Anki, and thank you for the interesting talk. I'm very passionate about plants. I can imagine your boxes can control temperature, water, moisture, temperature, water. A few parameters that you can control. But then I'm thinking about viruses and these pests, these kind of more difficult parameters. How are you planning to also think about this environment control, or what's your strategy?
Yeah, that's a good one as well. We are quite proud of not using pesticides. We don't want to use pesticides, and that of course brings out the pest question. How do we deal with them then? And the first and easiest answer is that we need it to be very, very clean inside our facilities. So we're using material that is inert. We're using basically clean stuff. So we also don't want soil or earth in our facility as well, and we don't want anything that tend to bring in pests with it. But then, of course, you can also apply. There are things you can add to that is not pesticides, but still reducing the risks of getting nasty stuff. But then you also have the benefit of using these closed modular systems, so that if we get something, we can A, detect it very, very quickly, and B, make sure to stop that in those specific boxes that something were to happen. Luckily, that doesn't seem to be the case, that we have to deal with that, but it is possible.
Great. And yeah, we can take the question right here in the front.
Yeah, thanks. Great talk. I was just thinking, like, how are you going to apply this to like larger scales? Like, for example, like farmers now, it is in soil, as you say. I see you have like a system here now which helps with Blomsterlandet. But like, for example, if you're gonna, is there gonna be possibilities that you might do something in soil testing, for example, or have them under conditions where it could actually be beneficial with the data for farmers who are doing it on arable land, for example, in the future?
Yeah, there's two parts to that question, or two parts to the answer of that. The one is that we are actually testing and comparing, okay, the results we're getting in the boxes, is that data transferable to growing in other medium, hydroponics and soil, etc. And generally, it is. There are differences, of course, but it is. And secondly, yeah, we are testing growing in, we have tested growing in soil in the boxes themselves as well. We prefer not to do that, but it does work in getting information and testing, just for testing purposes. So yeah.
And sorry, just to come on for the last one, the pests and example, are you going to maybe do some control tests, for example, because that's obviously a huge issue in arable farming, pests and disease and stuff. Would you introduce that into the boxes, for example, to see how the different things condition, you know? Is that another plan?
Kind of. We are in the middle of a research project right now where we is one of the industrial partners, and we do not necessarily that specific thing, but where we induce things that we want to test. But then we make sure to not do that where we have our large facilities. So that would be specific places with very extra regulated controls to make sure that we don't spread anything to everything else.
Thank you.
Great. Let's take a question over there as well.
Thank you. Great talk. You made it really interesting. So I have two questions. The first one was, as far as I understand it, like growing in soil, the way we're doing now industrially, is kind of destroying the soil in a few generations. Would this way of growing be able to be scaled to solve that problem? Question one. And then question two, when it comes to food, are you looking at optimizing the nutritional value of what you're growing?
Okay, that's a fun question. I already forgot the first question. There was...
Will this solve the problem with destroying the soil?
Short answer, yes. Long answer, we can discuss later. And on the second question... wait, what was that again?
So... let's say you want to make a fruit that is pure protein.
Oh, yeah.
Can you optimize for that?
Yes. That is a horrible problem to solve, is the short answer. Because you can't, well, you can, but you would need to have very difficult ways of, or very expensive ways to put that in every single box. So what we can do instead is sending samples to sites that already have more industrial ways of testing that, or setting up our boxes in places close to that, so we also don't have to send them very far. So it is doable, but it's a very tedious thing to do, so we can't really do it inside the boxes right now. But we have had a lot of discussions about that. We really want to do that long term, but it's a bit more of a expensive problem to solve. But we're looking at that too.
Great. Yeah, we have time for one or two more, I think. So let's take all the way in the back there.
Thank you very much. Looping back to the questions we had before about pests and the like, I imagine there would be benefit in having some kind of feedback loop, because in the conditions that are most conducive to good plant growth might also be very good for pest growth or disease growth. So when you provide data to a farmer and says this is ideal temperature and moisture, that might prove worse in the end because that also promotes pests. Do you have any thoughts about the feedback loop between testing it out in the real world and do you adapt your testing to match? If you understand my question.
Yeah, I mean, that's a bit tricky one. What we can do is, of course, or what we do when we have experiments together with outdoor farmers who grow in arable land, it's we take the job of making the experiments and figuring out what would be interesting depending on what what they have. What they can control and what they can work with, and then we can run that on a test outdoors on a smaller scale as well first. So it just becomes a longer process if there are risks like that involved, and then we can take that into account. But yeah, that's a very good point. It's important to make sure that we see the differences between growing indoors and growing outdoors if we want to apply it to the real world.
All right, great. So one final question for me. I'm going to take the opportunity. So what is kind of the initial reactions and responses or like opinions from farmers that you have approached? And do you have any initial sort of conclusion from like how to go to market on such a kind of traditional industry that farming is?
Yeah, that's that's a big question. The initial reaction is differing, to put it in one way. So we have different segments of the farmers that we've talked to. Some of them are very, very excited because they do see the same issues and the same problems that I talked about today. That is not problems that just came out of nowhere. That is problems that the farmers actually have. So there's a lot of farmers that are very interested in these kind of solutions and ways to both increase the revenue, but also decrease the impact on the planet and so. But of course, there are many very traditional farmers as well that really want nothing to do with this as well. So it's a big mixture.
All right, great. Here are some flowers. They're not Optima Planta flowers, but I hope you will like them anyways. Thank you so much.
Thank you.